So thank you, both of you, for being here. So that's the third part of our session. And we're going to finish to explain everything about ocean and why it's the lung of the planet. And maybe I will give a very short introduction on both of you. So Patricia, you've been an environmentalist for 30 years.
Yes, don't say it.
You're now the president of the Oceanic Institute of
Institut Oceanographic Palais, which is one of the very few and two rare sponsorship from a company, from a private company, to sponsorship science for ocean. And it's just like a little Villa Médicis, but it's for marine biologists. And they're very efficient, and they've been working for the last 54 years on protecting the Mediterranean Sea, and mostly on coastal areas and marine life.
Thank you. And you're also the spokesperson for the climate change platform.
Yeah, it's the platform Océan et Climat, Ocean and Climate Platform, which is a very genuine organization. Maybe we could see the slide, because it's something that raised up completely spontaneously for the COP21. Because remember, before the COP21, nobody would link the ocean and the climate items. But the climate, it's completely the ocean is at the heart of the climate system. So we decided that we should push all the NGOs, all the laboratory, universities. If we can have the second slide, maybe then you can see what the ocean platform is. See, you have all the NGOs, all the institutes. You have private and public. I mean, it's an amazing amount of capacity and knowledge. And so thanks to that, we're pushing the climate issues on UNCC, COP 24, 23, 25. We're pushing on biodiversity, because when we started, it was just ocean and climate, and today the real nexus, it's ocean, climate, biodiversity. Those are the real three pillars where we should really change direction, protecting the ocean, the climate, and the biodiversity, because that's the full support of the living system of the biosphere.
Okay, thank you. And Simon, so you're the youngest speaker on our panel today, and still you already lived 2 lives, at least. So you were a maritime officer, and now you launched, you're a social entrepreneur, you launched one of the most innovative social and environmental venture, which is Plastic Odyssey. Could you tell us more about Plastic Odyssey, please?
Yeah, so the idea with Plastic Odyssey is to make affordable solution to improve waste management in the most touched countries by this pollution, plastic pollution. So act on land, in cities, to prevent the plastic flowing into the ocean. Because what we've noticed is that there is only few plastic waste floating at the surface. So we are talking about garbage patch and everything, but it's only less than 1% of the plastic that is in the ocean. So what we wanted to do was to provide solutions that are on land to turn off the tap of plastic pollution. And we embark all these solutions on a boat, on a research vessel that will go around the world to promote and share all these solutions everywhere. That's the idea.
And you just say share. So what is the model? You really share?
Yeah, so the idea is to make open source solution. That's our core value, let's say. So beginning with plastic sorting, how we can differentiate the different types of plastic, then recycling, make new objects out of plastic, and then eventually converting, turning plastic that is the plastic that are not recyclable into fuel. So just taking all the different solutions that we can have from waste, from a bunch of waste, just make resources from local communities. That's the idea.
Thank you. How exciting. So, Patricia, now let's maybe talk a little more about the Ocean Climate Platform. And as the session team is Ocean, the lung of our planet, please explain us more in depth why ocean is so important for our climate.
Well, I think Jean-Louis did a little bit of teaching already, but just you have to remember that the planet, the ocean is only one ocean. That's why we said the ocean, and then you have internal seas, like the Mediterranean Sea, for example. And you have to remember that it's 71% of the volume of the planet, the surface, and the link between the ocean climate, it's going to be mostly on the surface, the temperature of the sea surfaces, who are going to decide the intensity of the storms, the intensity of the rains, and the intensity of the wind. So basically, I don't know if some people know that I've heard about El Nino and La Nina, which is a balancing trend of climate. It's very important for us because we know that if we put too much CO2 in the atmosphere, we're going to have a rising up temperature, and those rising temperature in the atmosphere are going to rise the surface temperature and even the one below. Last year, the team of the Institute went for a dive in November in Porcro. No, sorry, in Corsica, and they were at 44 meters down below, and the temperature was 24 degrees, which is absolutely, that was unobserved before. So we have heat waves on the surface of the sea, and then it has an impact on the oxygen. For example, everybody can make the difference between a cold Coca-Cola and a hot Coca-Cola. The bubbles in the hot one is going to be smaller. So the higher the temperature in the sea is, the lower the oxygen. Then we have the problem of acidity. And a lot of marine organisms need they have shells, and so they need to calcify the carbon. And so if you have a lower acidity, you cannot make it.
And maybe just on this, because we talked about the capacity of the ocean to absorb CO2, but then it becomes more acid. That's the fact that it absorbs more CO2 that becomes acid.
It's a story. You know all those little, like the piece of sugar who makes like in Japanese games. So when you have an impact, then you will have another, and then it's like a whole chain, an whole trophic chain who's going to be, and it's really hard to restore, and because then the time of restoration is really long. For example, yesterday someone said you have the lifetime, then you have the lifetime, and the living organisms need a longer time. We've been restoring a laguna in Les Ambiers, but we won't see results. The closest result we can see is going to be maybe 6 months or 1 year for the organism. But for example, for the Posidonia, it takes 100 years to make 1 meter. So we have a real ratio time. But we have also because we always think about the ocean and the CO2, but just remember something very important. Every time you use water, you get in the loo in the morning, you flush, you already send something to the ocean. Whenever you use the water, even if you live in a very remote place away from the ocean shores, every time you use the water, whatever you put in that water will end to the ocean at one moment or not. So, and the chemical stresses today in the ocean are very high too, because we always talk about the plastic, but you've got all the chemicals, all the hormones, whenever you take a pill, whenever you take something, even when you drink a Ricard, you will find it in the ocean afterwards. So we have to be very, very aware of whenever we use a tap or whenever we use something with the water, it goes to the ocean. So it's a huge circle, and biodiversity is in between that circle, because the climate has a real impact on biodiversity, and the biodiversity needs a balanced climate. So it's a real circle, and we live in that circle of life, that circle of biosphere, and we have to be aware of those three important protection: climate, biodiversity, and ocean.
Thank you. And Simon, Patricia just talked about the different pollutions that are in the ocean. And so you know a lot about plastic. Can you tell us more about plastic and also the other pollutions?
Sure. As Patricia was saying, plastic is the most, let's say, visible and known pollution, but that's actually not the worst. And we always forget to talk about pollutants, the different pollutants that we put, but also fertilizers from the agriculture. When we put all these nutrients into the ocean, the thing is, it triggers a bloom, massive bloom of life, of algae, usually, and just rub the oxygen, so that it creates then dead zones and destroy biodiversity. So they are very hidden pollution that we always forget. But coming back to plastic pollution, it's also the same, actually. We think it's visible, but it's only a tiny fraction of the problem. As I was saying, there is only 1% of the plastic that is found when we collect and when we try to count how much plastic there is at the surface. we only find 1%, something like that. And it's actually called the mystery of plastic, because today scientists don't know where is all this plastic that we've been putting in the ocean ever since. It's roughly 80 million tons of plastic that we've put so far, and most of them are just on the bottom of the ocean. So when the plastic enters the sea, it just sinks on the bottom because it's heavier than water, usually. And some of them are floating, but soon they are degrading into microparticles and then nanoparticles, and then enter the food chain. And so there is a recent study saying that we eat every week 5 grams, you might have heard of that, 5 grams of plastic. So that's quite frightening. We don't ever see that because we breathe plastic, we eat plastic, we drink plastics. It's everywhere. And to give you a funny story, we heard about an expedition in Austria led by the Walter Munk Foundation. And it's quite interesting because they've been analyzing the water coming out of rocks, so on the bottom of a lake in Austria, so in the Alps, and they found nanoplastic. The water had been filtered by the rocks in the middle of the mountains, and still there are nanoplastics in the water. So just to give you the idea that collecting plastic is impossible. Even the rocks can't do it. So the only reasonable thing that we need to do is just stop putting more plastic, stop putting more pollution, and just letting the nature recover the biodiversity coming back. And that's, I think, when you let the nature alone, let's say, when you don't harm the nature, then it recovers quite easily. And there are also other pollutions, because I used to be a merchant navy officer, so I was working on big container ships, cruise ships, and there are also quite a lot of pollutions linked to that. 90% of the goods that we consume, whether textiles, everything, are transported by vessels, by the maritime ways. And the thing is, these vessels use heavy fuel, so it's like the worst fuel you can have. And thanks to regulations, now it's getting better. And beginning on January this year, the sulfur in the fuel has been banned, reduced. So ship owners have to put scrubbers. So that's systems that just showers the exhaust gas. So just put water, rain at the exhaust pipe, and then you clean the gas from sulfur. But usually what you do with the water, it's in open loop. So you take the pollutant from the exhaust gas, and then you put it back in the sea. So that's crazy. And this is what it's doing now. What we are doing. So we need to push for closed loop system at least. That's one big thing. And there is also invasive species that are also quite regulated in the shipping industry. We have ballast water, so water that are used for stability in the ships. And the thing is, and fooling as well, it transports invasive species. It's also the same problem with microplastics that act as a raft, just taking all the bacteria and pollutants, absorbing everything, and just transporting everywhere. So all these invasive species are transported by ballast water or by microplastics, and this is all invisible. So that's also challenging. And the last one I wanted to talk about is noise pollution. Because, of course, when you have such a big vessel, you have a big propeller, and you create a lot of noise. And this is also quite harmful for the marine life. So this is all the different pollutions that we know today. Ship owners are doing the best to prevent, but there's more, as we saw, to do, especially on invisible pollutions or that are not released in the media.
There's another impact also very important. As I said, all the life really deploys around the coastal areas. And actually, that's where it's going to be worse soon there, because with the rising, it's not the level of the sea that rise, but it's the waves and the storms. I mean, before Christmas, all the water in the Marseille harbor gets out of its bed. I mean, so basically, all the people and the cities are going to build walls and fences, and that's going to destroy even more habitat. So we are really on a vicious circle, and we do have to think about nature-based solution or nature-inspired solution, for example, like biomimicry.
And you told me that you had some special coastal ecosystem restoration programs.
Well, for example, yeah, we do use whatever we work on is always nature-based solution, because you can't fix something when it's broken if you don't know how it works when it's okay. And basically, all the best solution comes from the nature. All the answers are knowing, exploring, and understanding how nature works. And for example, when we get a problem with waves, we will put a fence, but one day or the other, that fence is going to crash, and if the water gets the other side, it's not a better issue neither. If you look at how nature protects the shores, you will have mangroves, corals, you will have seagrass bed, and if you have a very seagrass bed, as we have in Les Ambiers, it's amazing, because when you walk around with the kids and there are waves, and then the wave stops, just like it's swallowed by the laguna. And the kids say, oh, the waves are dropping. But it's not the waves dropping, it's just the seagrass doing that movement under, and the mechanic of the wave gets completely taken by the seagrass waves. So there's so many absolutely genius solutions in nature. That's called biomimicry. And just never forget that the ocean, the life started in the ocean. So all the species in the ocean are so clever. We saw the corals reacting, in effect, with the sunscreen. I mean, marine life, it's much older than the life on Earth. And all the species get so much information to tell us to how to have a better balance with the biosphere. Because the problem that us humans are very clever, we have a really gorgeous brain, and we have invented a world full of technology, and progress for us is technology. But we still have lungs, and we still have a liver, and we still need to have a biological life, and that's the biosphere. So we do have to make the biosphere join in the technosphere. And if we have to use our technology to go slowly to something more respectful for the biodiversity, for the ocean, and for the climate, because that's the planet we can live on, and not the technosphere. So we need to use the technosphere to enhance our knowledge and our ability to understand the most quick as possible how nature works, because that's, I think, it's the best way out for us for the future.
Yeah, thank you. And could you give us just one example of coastal ecosystem restoration that you
Oh, well, we're restoring a laguna from five different points. Basically, they are destroyed habitats by human activities. So we're just trying to make the nature goes back. For example, it will be places where you have a wasting plant, the water, when you how do you call it, station d'épuration, what do you call that? Anyway,
wastewater treatment.
Wastewater treatment. Today they're better, but once upon a time they were not that good. You also have, when you have excess, for example, oysters breeding. Anyway, so restoration is okay, and it has to be done. I mean, it's important to keep the spirit that we can still repair, not everything, but we still have to save all the ecosystems we can, just because they are libraries, so that's why we have to save them. And then, for example, we were going to use something, talking about biomimicry. The paint you will use on the boats for avoiding the fueling, all those plants who get stick to your boat, usually they use very strong chemical products and very heavy metals products in bed. So if you want to know how nature does that, put a mask, go under the sea, and see where are the clean surfaces. And then you just scratch a little bit, open and looks the molecule, and then you make a biofilm mimicking that natural molecule, and then you have a boat, very clean, and you don't have any more chemical stressors in the sea, because those chemical stressors are really changing the biodiversity. We've observed on seahorses, because we do like seahorses because it's the male. The daddy does all the job. The male bears the baby. And you know, chemical stressors are very impacting masculine, the man fertility. And we've been on 5 years, 5 generations of seahorses. The DNA has changed because chemical stressors. And we are at the end of the chain food. So we have to be, I mean, if one day we have a very, very healthy ocean with a very, very safe biodiversity, we will have a nice climate and we will have a very blue future. So the ocean is our mirror. I mean, the best will be, the more healthier he'll be, and we will be both safe. So we have to think as the ocean like a crash test of our ability to do a better job. Whatever you do in your life, from breathing to drinking to eating to whatever you do, has an impact on the ocean. So if you change your behaviors, if you change the way you move, the way you eat, the way you think, the way you learn, you will have a gorgeous impact on the ocean, I think. And that's great, because it gives you a safe way to walk through.
Thank you very much. And that's the end of our session. So I'd like to thank you, both of you.